Hi guys. Let's wait for a couple more minutes for the people to join and then we can start. Okay guys. So I think we can start today and today we'll be basically going through the reviews what we have learned on the last date and today we will go through the deep dives of how do we actually proceed a LLD interview round. So let me share my screen and then let me help you guys. Yeah. Can you guys see my screen?
Yes.
Okay. So starting from the very basic thing what we learned in the last class, which was the solid principles. Can someone explain to me what we read in the first class and what does solid mean? Like individually, each of the person can just explain what S meant, what does O mean, what is L. Yeah. So let's start from that. Anyone who would like to start with what S means?
Yeah, man.
Yeah, go on.
Yeah, so S means single responsibility principle,
Okay.
which means one class should have only single responsibility. Okay, like one class does not have multiple things to implement.
Hmm.
Okay, and O means open close principle. That means open for extension but close for modification.
Okay.
So yeah, if we need is like we only have to extended the interface. Don't modify that class. Okay.
Hmm.
Yeah.
Correct.
Yeah. And L for Liskov substitution. Sorry, Liskov substitution.
Yeah.
Oh yeah. So it means ki our child class should not narrow down the property of our parent. Okay. It should
Correct.
extend that thing, not narrow down. And
Hmm.
interface
Yeah,
segregation.
explaining once more to everyone just to make sure that everyone is in the same picture. So what what was your name, man? Bhaskar. So what Bhaskar said about solid, S means single responsibility principle, and what we want in each class is to have only one responsibility, and we do not want a single class to have multiple responsibilities, what we learned in the previous class. And why do we not want more than one responsibility? Can someone explain that? Yeah, Rabindra, were you there in the last class?
Yeah, Akash, I was there, but I was not attended fully. I was like middle of the class. I was joined.
Okay, okay, no problem. Divyansh, can you explain why do we need only one responsibility per class?
Because
Yeah.
हेलो am I
Yeah, yeah.
audible?
Yeah, you are audible.
तो एक्चुअली हमें इसलिए चाहिए क्योंकि अगर मान लो हम अपनी क्लास में कोई चेंजेस कर रहे हैं तो हमारी टेस्टिंग हमारी आसान हो जाती है या
Hmm.
और जब हमारे सिंगल प्रिंसिपल्स रहते हैं तो अगर मान लो हमें कोई ऐड भी करनी है फंक्शनैलिटी, तो हम उसको अलग से पहले टेस्ट कर सकते हैं कि वो सही से वर्क कर रही है या नहीं कर रही है, फिर
हम्म।
हम उसको अपनी मेन क्लास में ऐड कर सकते हैं। हमें अपनी मेन क्लास को दोबारा से फिर फुली रीटेस्ट नहीं करना पड़ता, हमारा टाइम बच जाता है, मेंटेनेबिलिटी इंक्रीज हो जाती है।
ओके, एनीथिंग एल्स? और कोई
हम्म,
ऐड कर सकता है सॉलिड में कि सिंगल रिस्पॉन्सिबिलिटी क्यों होना चाहिए?
So we can maintain that thing, and also like we can use that thing in another place, like we reduce the
Correct,
duplicate things.
correct, right, exactly. So we don't want the code to be duplicated everywhere. So we are saving ourselves from duplicate code. We can use it as per our convenience and we can call from anywhere. Now, going to open close principle, what Bhaskar said, we want our classes to be open for extension and closed for modification, right? Why do we want a class to be open for extension? How does it help? Anyone? We can add, let's say if we have one vehicle class and we are implementing a vehicle class in a car and a motorcycle, we can again implement and we can add more vehicles, right? So we can say that it is open for extension because we are using the same base class, which is the vehicle class, for other subclasses as well. For example, truck or whatever different similar classes are there, we can just implement the vehicle class and we can say that it is open for extension. Then the tricky one was Liskov's substitution principle, and it said, as Bhaskar explained, कि we do not want the subclass to narrow down the properties and functionalities of parent class. We don't want subclasses to narrow down. ठीक है? This everyone understood, right? And this is because whenever if we are using any class and we are narrowing it down, that definitely means that we are violating the Liskov substitution, and in that way we won't be able to use all the functionalities of the parent class. And if we are narrowing it down, it does definitely mean that it's a very bad quality code. Okay, now coming to I, can someone explain what I was? What was I? Anyone?
Interface segregation.
Interface segregation principle, what does it say?
So like one there are two methods. If there are two methods, so for one thing, so for cycle, so we can't accelerate, but for bike we can. That. So for that we need to add another class of for cycle.
Okay, this is uh, okay, but a better example here could be where which we discussed on the last day was restaurant employee. So if we have a single interface restaurant employee and it has all the functionalities of take order, cook food, and wash dishes. If a waiter class is implementing a restaurant employee, what will happen over here? He will not be cooking the food and washing the dishes, or the chef won't be taking the order and washing the dishes. So what we do is, on the basis of the functionality, we only want the very necessary attributes in a single interface. So that's why we segregate the interfaces on only necessary attributes, so that each class can implement that interface and does not throw any error or does not have to worry about the other functionalities which it does not even import. So that's what we learned in interface segregation. And what is dependency injection? What is D? Dependency injection. What does this mean? Can someone tell me? You guys able to see my screen, right?
Yes, yes, sir.
ठीक है, okay. Yeah, tell me.
Yeah, so dependency injection said like we should depend we should depend on interface rather than its class, concrete class.
Exactly. Yeah, so it's very simple. We should not. So on the last class we discussed about MacBook, and let's say it currently have a wired keyboard and a wired mouse. In the later part, if we really want to have a Bluetooth mouse or a Bluetooth keyboard, so again, if we hard code the objects in by new keyword, we won't be able to, like, we will have to again change the entire code of the MacBook. That's what we discussed in the last class. So for that particular reason, what we want to do is to have interfaces which will be passed at the time of the runtime, that we want this particular object or this particular object in the form of constructors, in the form of parameters in that constructor. So that's how we say key we are doing a dependency injection over here. So instead of doing or using a new keyword for initializing the mouse or keyboard, what we would use is to have a constructor which will directly take the objects in the form of parameters in that MacBook class. And this is how we would make sure that we don't have to change any code in this particular MacBook class. Even if the mouse changes or keyboard changes, we are clear on that. And lastly, we learned about dry. We just read ki we would write code in such a way that if we are using some particular logic again and again, we would write at some place which we can call at any point of time. It's easy to debug, and we can reuse it as many times as we want. So that's what we learned in the previous class. Today we have just reviewed the solid principles, and I hope everyone is in line with me. There's one more thing before actually jumping onto the design patterns and jumping into how we do an actual LLD question. How do we actually solve a problem in an interview? Before that, we need to know what an activity diagram is. We won't be going into the very deep of what an activity diagram is essentially a basic flow chart, if you would have to understand. So if let's say you are given a problem, how would you basically draw it in a diagrammatically way to show that its flow is going from the left side to right side, or how do you basically perform some action? You will have some choices, you go this side or that side. What will happen if you choose the left side? What will happen if you choose the right side? It's just a basic flow diagram, if I have to tell you in short. So these are the activity diagram notions. I would just come back to this picture again, but before that, let's say we have a scenario where we have to process a simple order. Let's say you book an order and Amazon receives the order. So how would this flow actually work? So here itself, I'll explain to you what does this circle with a dark, like it's a completely black colored filled circle. What does it mean? So starting from here, I'll just explain to you that it is the initial node which portrays that it's a beginning of an action or an activity. If it's a circular node which is having like concentric circles, it means that it's the end of the actual final, it's the end of the activity. So that's how we define this. Now starting from this, right, what will happen if Amazon receives an order? Now I have booked an order. What will happen? First of all, it will have uh, parallel, what do we say, parallel flow for actually sending the order and doing the inventory stuff. And the second part would be to send the invoice in the mail or whatever the person has chosen in the application itself, in the Amazon itself. What will happen here is that in the left side we have, this is called the arrow with a rectangular box. This is called fork node. So we split a behavior into set of parallel or concurrent flows of activity diagrams. Okay. So here we have two parallel flows that would be running. First would be to actually go to the inventory, fill the order, pack the boxes, and then uh, the time would come that if he has to send the delivery overnight, or if he has to send the order in a regular delivery, if it's a 2-day delivery or 3-day delivery, whatever. If he's a prime customer, will have some choice, right? So this diamond shape you are seeing right here, everyone, this is called as a conditional check, a decision node. This will basically tell you that you have a decision and you're going to the either to the left side or to the right side. So we have a decision over here to choose whether we want to do an overnight delivery or do we want to do a regular delivery. So here we have on the left side we have to arrange the overnight delivery. So we do that. The rectangular box is called as an action or as an activity. It could either be a single instruction that you can see over here, or it could also be multiple instructions, which is called as an activity. Action is one, and activity is a set of actions, just for your information. So it does the overnight delivery and then it comes back to the same position where the arrange regular delivery would come. Either it does the overnight delivery or the regular delivery, and it again comes back to the same point, and that is called as the merge node, where the different decisions that was created before by the decision node comes back to the same point. It is called as merge node. And then if you look into the right side, the invoice has been sent to the user, the payment would have been received, and eventually it comes to the join node. And the join node is called as again a set of parallel or concurrent flows that come back into a same place. Once that is done, we will just end this flow. So I hope this is clear to you. Now I'll just go through what each notion means over here. So I've already explained this rectangular box is called as an activity. It can either be a single action or it could be a set of actions. An action is a single task that needs to be performed. This arrow shows the sequence of execution. Where does the action actually flow? The sequence, right? The object flow is again shows the flow of an object from one activity to another activity or an action. This black dot, which is filled with black color, is called as initial node. The concentric circles with a black node inside is called as final node. This is called as an object node. Uh, that is, uh, you can say that it represents an object that is connected to a set of object flows. Then we did not use this over here, so I'll just uh, explain. So this is fine, okay, right? And then the decision node, as I already told you, we have a condition where we either go to the left side or to the right side. The merge node eventually meets the decision nodes at a single point. The fork node splits the behavior into two parallel actions, and the join node merges them two into a single uh, point. So I hope this is clear to you. Is anyone having any doubts or any problems over here? If not, just let me know. I'll just look into the chat. If anyone has a problem or any confusion, do let me know. Everyone is clear? Just give me a +1 over here in the chat. Okay. Okay, cool. Now coming to the actual design patterns. So this is what we were all curious to study, right? And this is a very, you could say, important part in the low level design. We have different types of design patterns. One is the creational design pattern, the other one is the structural, and the third one is called as behavioral design pattern. So we'll learn each of them. There are total of 23 design patterns, which are the very, uh, you know, most commonly used ones. We would be going into the major ones, and today also we have 5 6 design patterns that we'll be covering. And later you would also have to study a few design patterns by doing some investigation, by solving problems which I would be giving to you. And whenever you guys have any doubt, you just let me know. So we are covering the very important design patterns, and these are very frequently asked in the interviews. So as you know, like, creational design pattern is a type of design pattern where we are mostly going to work around with object creation mechanism. Okay, so whenever you see that you need to create some object, or you need to see that you need to uh, have a factory kind of pattern, or I'll explain a lot more in the detail in the upcoming slides. But for now, you can say that creational design pattern is mostly about object creation and maintaining it over here. The structural design patterns is a kind of design pattern where you have smaller objects and you want to combine those objects into a larger structure, and you want to make sure that your structure is flexible and efficient all the time. The behavioral design pattern is a very important design pattern that, mostly focuses on how objects interact and communicate with each other. So you will be having multiple classes, multiple objects. How do you interact with each other is what we are going to study in the behavioral design pattern. So the very frequent ones that come in a lot of interviews and you'd be using a lot is the singleton design pattern. So I'll tell you what a singleton design pattern is. And so by definition, singleton usually, I mean, by English language as well, singleton means that it's a single object over here. Okay. So the question is, while creating a low level design problem, why do we only want a single class or single object of a class? Can someone explain this to me? Why do we not need more than one object of that? Or any real life example where you could think of that we have one object of that and we are not looking to create more than one object. So creating more than one objects will create issues for us. If you have encountered any kind of problem till now, anyone, if they have any context about it? Can you think of databases that we don't want to have multiple databases, right? If you guys have already done projects on I guess what code design and all, right? The So over there you would have seen that you don't want to have more than one object of a database. If you have more than one object, what would happen? Can someone tell this to me?
We have to maintain both the objects.
And
Duplicates will be there.
correct. If we have more than one objects, the most
Let's
important.
say we want to some search information, we have to search in both of those. We want to meet some changes. Let's say we are adding some data, so we have to add in both of the databases because consistency should
Exactly.
remain.
Yeah, that's
Right.
a very good example, right? So as you said, if we have more than one objects of a database class, we do not even know which is the master node or which is the master database and where are we actually saving our data. So if we want to save the data, we'll only save to one, but while querying, we'll still not know which one to call. So in this case, if let's say any of the functions is trying to call one more object, is trying to create one more object, do we want to create one more object of that class? We should not allow that case itself, that you have written a function or a class of create object. So let's say this is a class of db and it has a function, let's say create db instance. If you call this function once, what will happen? It will create a db instance and it will return to you. Okay. What will happen if you call this function again? Will it return you one more object, or should it return the same object if it is already created? Tell me. This is obvious, right? What is the doubt over here? Create db instance. We want only one object over here. So if we call it once and we got the object, what will happen if we call it again?
Another instance will be created.
Why would another instance be created?
It will return the already created instance handle.
Yeah, correct. So we do not want to create more than one instance, that we know from here. What we discussed, it will have a lot of problems. So
Can you
only,
repeat what you just said? I
yeah,
actually got disconnected, I think.
okay, no problem. I'll just repeat it again. So
Yeah,
what
yeah.
we discussed is that if we want to have a DB instance, we only want to have one DB instance, right? So let's say there's a code to create the DB instance. Create DB instance ka function is there. What does it do? It takes some parameters and creates an instance and returns it to you. So I'm asking you that if I call this function again, let's say somehow I call this function again, create DB instance, what should this do? Because the problem statement here is we want only one instance of that DB.
Yeah, it should return the already created instance.
It should return the already created instance, right? Instead of creating one more. So how can we make sure that the same instance is being returned from here and we are not creating one more instance? So I'll not put a lot of pressure on you guys right now. So here I've written this class. Okay. So let's assume that this singleton class has an object singleton and it returns the value. Okay. So if we call this class singleton of get instance, what does this do? It smartly figures it out. It very smartly figures out that if the instance which is it has already pointed to over here, if it is null, then only it will return a new singleton value. If it is having some value, it will return the straight away instance, what it is already pointing to. So do you guys think this would work? Because I am already pointing key, I have an instance in my singleton class of the singleton object itself. This value would be some parameters of the DB, let's say. We pass on this value and this will create the singleton object and it will return back to me. So do you guys see that this is going to work and how smartly we have made sure that even if you call the singleton get instance as many times as you want, you'll still have the same one instance that you've created in the start. Did you get this?
Yeah, man.
Yeah, so cool. So this is what we have in the singleton design pattern. We always want to make sure that if we want to have some kind of a control where we want to have only one instance of DB, or let's say some kind of a variable where we don't want to have more than one instance of that, we would follow this singleton design pattern. I hope this is clear to everyone, right? Okay, cool. If anyone has a problem, you just let me know anytime. I'll just repeat it back so that you don't miss out on anything. Now we have the builder design pattern. Builder design pattern is also a creational design pattern that provides us a way to construct a complex object very smoothly. So let's say we have a class now, and let's say we have a vehicle class and a vehicle. So we have over here a vehicle. Okay. In general, what does a vehicle have? It will have a lot of parameters inside it, but we don't know which uh, which all objects do we know. I mean, let's say we have a vehicle, right? We by default know what is the engine of that. Let's say this is very common in a vehicle. We know what all brakes are going to be applied on that. We know the color what it is going to have, or the most important ones. There would be some mandatory fields and there would also be some optional fields which we don't have to worry, like let's say the color of steering wheel, the interior, the type of uh, the seat covering that it will have, right? These are like optional, we don't need to worry about it in the very start when we are creating an object of vehicle. So for that particular reason, if we have, let's say यहाँ पे 100 parameters and we want to create an object of vehicle, what would happen? I'll pass vehicle, I'll pass engine, brake, color, dot 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 करके everything inside a vehicle constructor, and this would be passed on as a parameter, I'm assuming, right? So this will be a lot of parameters that I have to maintain, and again I'll have to do this dot x is equals to x, this dot y, this dot z, and it will be a lot of work for me. As you can see here, 100 parameters is very difficult to manage for me. So what I'll do here, I'll just have the very mandatory fields. So let's say there are three fields: the engine, brake, and the color. So here is engine, here is brake, and there is the color. So I'll just pass on these three values as the mandatory fields, and the other optional fields can be handled using the builder design pattern. Okay. So here we have taken an example of a person. So what a person has is a first name and a last name as the mandatory fields. The age and the address is like optional. Okay. So what we have done here is we have created a static class builder, and the mandatory fields which I told you is first name and last name. So what a builder class actually does is it returns the same object by taking, let's say we have an int age, and what this will do is it will take the object of builder, and what it will do is it will just append this dot age is equals to the age that we have passed, and what it does is it returns the same object again. So what will happen if you see into the place where we are actually calling it? So what we have done here is we are creating a new object of person builder with John and Doe as the mandatory fields. But additionally, what we are doing, it returns me a person object itself. Now what we do is on top of person, we again call this function age, which we have written over here. As you can see, what does this do? It appends the age with the age that we have passed, and it again returns me the same object that I have used. So what happens? The first new person which we have written, it returns me the person object. On top of that, we again call this age. This also returns me the person object. So we can again call some other function, which is like address. It takes the builder and it again returns the same object that I've used. So here I have address. I can pass some address over here. And since we know that this address is also returning me a person object, I can again do a dot xyz, any kind of function call over here. And eventually we build that object. So this person will have any kind of parameters that we want to pass, and it will still be easy for us to maintain if we have hundreds of parameters or whatever many parameters that we have. We just only need to worry about the mandatory fields, and on top of that we just call dot whatever is the parameter name or the function name that we have called. And this is a very, I mean, very used design pattern which would come in a lot of places wherever you have several data fields that you want to use. And I hope this is clear to you. Is anyone having any problem understanding this, that why do we even need a builder design pattern? Let
Yeah,
me.
but I have one doubt here.
Yeah, go on.
So in Java, basically, as you said, like we can have multiple variable like first name, last name, age, and address and all.
Yeah.
So when we are calling this person class in any of the subclasses to
Mhm.
create any builder build method or something. So as you said, we need to pass only the mandatory fields.
Yeah, correct.
Yeah, but in
Because
the
go on, right?
yeah, but in the construction, you mentioned all the four parameters, right? So if we pass only two parameters, then it will create an issue. No?
No. So here, as you can see, we have created a builder class as well. So what I explained to you over here is, if you want to enforce the use of builder, what you have to do is you have to basically write all the functions. Like for example, I'll tell you over here. So this is the builder class that we have written, right?
Yeah,
What this does is, we don't need to create an object of this because we have written it in a static class
yeah,
builder.
exactly. Yeah,
So we can use it as we want. So what happens over here is we take the builder function, we take the constructor of builder, and we pass on the very important parameters or the what do we say, the mandatory fields over here. Okay,
Yeah.
this will make sure that we have at least all the major fields that we were trying to pass in the builder class, and that would be populated. So you don't need to worry of calling this
Oh,
person wala object ka constructor.
okay.
Okay, this is actually a private
Yeah, it's
private
private.
object, so you won't be able to call from the other classes. And we have written it in private just to make sure that we are using the builder class instead of using the person class over here. Did you get this?
Yeah, so on top of person, we are creating builder class to give the mandatory fields, and we can assign all the optional fields also, kind of.
Yes, you got it right. So builder is kind of a pattern where if we need to break down multiple parameters into smaller chunks, right? Then only we would be using this. If we have, let's say, fixed number of parameters, we can straight away call the person class, and we don't even need to have a builder over here. We can straight away call this thing then.
Okay.
Yeah, did you get this?
Yeah, got it. Thank you.
Okay. Anyone having any doubt over here? Okay. Yeah, cool. So both of these, the singleton and the builder, were a part of creational design pattern. As you can see, we are trying to create the objects over here. Now again, we have the factory design pattern. This is also a part of a creational design pattern where uh, you could say that we give the power to a factory class which will help us to create the objects for us, and we won't be writing new keyword to create objects for us every time. Okay, so let's say we have a vehicle interface and we have a function start, we have a function stop in that vehicle interface. What is happening here is we have a car and a bike, a car and a motorcycle, which is implementing vehicle class, both of these. And we are just overriding the function start, we are overriding the function start and stop. So this is a basic template that we are trying to use a car and a bike. Now let's say we want to actually create and we want to use the car object somewhere. So what will happen? How would we use it? First of all, we have implemented this car as the vehicle, and similarly, we have implemented the bike as the vehicle. What will happen if we want to use car ka object? We'll have to pass and we'll have to call new karke car ka object somewhere, right? But if let's say we have multiple vehicles which are implementing the vehicle class, and we want to make sure that we don't want to use new karke car, let's say we don't want to use new car or new bike, and we want to delegate it at the time of runtime, or let's say we want to delegate this usage to a class, a factory class, instead of calling new car over here and then passing some xyz whatever fields. So for that particular use case, what we have done here is we have created a vehicle factory. And what does this do? It returns me a vehicle. So vehicle can be of type, vehicle is implemented by car, bike, and other classes also, right? So it will just return me a vehicle, and it has a function create vehicle, which is interface. So if we have not implemented it over here, what would we do over here is we would again have concrete factories like car factory, motorcycle factory. And you'd be asking me, why did we even write a car factory and motorcycle factory which is implementing a vehicle factory, right? So what happens is we want to choose this car factory in case, let's say, we have Mercedes ka class, we have BMW ka class, we have several other classes. So all the functions of a car would be handled by the car factory at the time of runtime only. So we would just need to call this car factory ka function create factory, and it will create a new car for me. And if again for a bike we want to call the function create vehicle, it will call the motorcycle for me. So if you just look at the client code, right, So this vehicle factory, car factory is calling this new car factory. This is required for me at the very start. Now, if we want to use a car or a bike, or let's say anything else as well, right? So we would just need to have one place where we would say that we need this particular car object, or we would need this particular bike object, and then we can straight away call the function of that. We don't need to handle the actual uh, object creation of that particular class, and we can handle it from here itself in the car factory or the motorcycle factory. So we are kind of
Where is the create vehicle function defined?
create vehicle is over here inside the interface vehicle factory,
Oh,
and we are trying to implement the vehicle
okay.
factory.
Create vehicle, a vehicle is created and it is returned.
Yeah, right.
Okay.
It will return a vehicle to me. Yeah. So as you can see, we are trying to create a motorcycle using the factory. So what would we do is to have a motorcycle factory, and then we can create the function. We can call the function motorcycle factory dot create factory. It is implemented by the class vehicle. So vehicle is the parent class, and then we can call motorcycle dot start or motorcycle dot stop. We don't have to worry key which kind of a vehicle is that. So I hope this is also clear
No,
to you.
here we have used motorcycle factory, right? Then that means I know I will be going to create a motor vehicle.
Here I'll tell you why I have used this motorcycle factory and a car factory. So the thing
I
is,
mean, if
let's
you
say,
want to build something on car like Swift, Maruti,
yeah,
then car is a bit. I mean, car acts as a parent class.
yeah, correct.
Okay. So suppose if I want to create a vehicle, but I don't know which vehicle I will be creating, then
Yeah,
I will be using a vehicle factory, right?
let me tell you over here. We have a car, we have a bike, and let's say we have a factory class. This is the vehicle factory. So what we can do here is we have two options. Inside the vehicle factory, we can have if करके conditions, that if the type of vehicle is a car, then return a new car. This is one of the ways. Else, if we have a bike, just return a new bike here. This is one of the conventional ways of using the factory methods, and this will work, right? We can return a new car, new bike. But what happens here is, we again, if we want to have, let's say, a new truck or something, what will happen in this case? We would have to change the vehicle factory ka logic. Did you get this? And this is not open for extension. This is kind of modification which I'm doing to vehicle factory. So instead, what I'm doing here is, I have a vehicle factory which has a function create vehicle. Now, create vehicle is there. Now, on top of this, this is basically implemented by various different classes like a car factory, bike factory, and truck factory. Now, individually, each of these classes have a function to create a vehicle, and it will return me a car over here. It will return me a bike, and it will return me a truck. So, can you see here that even though, let's say, I know what kind of a bike I want to use, or what kind of a vehicle I want to use, but still I can see that all the function, all the creational, you can say the task to create an object of car, bike, or truck is actually delegated to the create vehicle factory, and it is not handled in the runtime of my class. So the main client code does not have to worry ki which object do I need to create now. Everything is being handled by the factory itself. if you are able to understand this. So here, if we would have used the vehicle factory ka hi object over here, we would still need to pass ki either we want to have a car or a bike in the parameters. Did you get that? And if we pass some parameters over here, the problem will come over here that it is not open for extension. We will just check for condition that if okay, we are using a new vehicle factory and we are passing a car as an enum or some string, okay, we would have some problem in actually extending this logic of creating the vehicle factory. Somehow we need to know, right, ki at any point of time we either need a car, a bike, or a truck. So this way we will delegate our tasks to the vehicle factory, which is having only one task to create a car, a bike, or a truck. And rather we should not have any kind of hard coding to create a car, bike, or something in the client code. We can have a factory method that we can call, that is fine, but not of the actual entity that we are going to use over here. Is this clear to you? Is anyone having any kind of doubt over here? Or
So, according to this factory design pattern, so later point of time, if I need to implement any other kind of vehicle like bicycle or something,
okay,
so we only need to write the factory class for that bicycle. We don't have to touch the vehicle class like parent.
no, vehicle is a different thing. So let's say you are trying to add a new thing over here, as you said, right, a cycle.
Yeah.
So we have a new class cycle which you created. Now what would happen? How would you create an object of this cycle? This is the task. How would you
Yeah.
do it?
For that purpose, we can create implement the vehicle class, and we need to override the create vehicle method inside the vehicle class, right?
Inside the vehicle class is like a actual vehicle. It does not have create vehicle wala cheese. It will have the properties of a vehicle. It can start, it can stop. You can have those function in the bike, in the cycle
Okay.
class.
Okay.
But
Create vehicle is present in vehicle factory.
correct, exactly. So
Okay,
how
so we need to implement this vehicle factory in the class by our cycle class, right?
yes, you would have to create it this. You would have to create one cycle class ka factory just to make sure that your cycle ka factory is also returning you a cycle from here. It will return you a cycle.
But if I know I want to create a cycle, I will directly create a cycle, right? Why should I go through Cycle Factory?
Okay. So now you are saying that you want to have a cycle here, you want to have a bike. So let's say, yeah, there are thousands of object creation that are happening over here, and there are four different classes. Okay. What would happen? You will write a cycle c is equals to new cycle, isn't it?
Yes.
You will pass on some value here. And again, you will have some bike. So you'll call the new bike. You'll have some parameters again over here. Now, the thing is, can you see you have called new cycle, new bike, and let's say we have thousands of creations. Hold on. And what are you doing here? You're calling new cycle again. You're calling new bike again.
Yes.
So do you see that you're doing some kind of redundancy? And this is a very bad practice to actually create an object and you're reusing, you're duplicating your code of calling new cycle, new bike every time.
Okay. If I have a factory, then what will I do? Still, I have to C is equal to uh, car factory create vehicle.
Yeah.
B is equal to car factory dot create vehicle. Right?
You have one car ka factory.
Yes.
Now what would you do? You just call car factory dot create
Create
vehicle.
vehicle. Create cycle. Sorry. Create car. Create vehicle.
So
Okay.
you can
Yes.
see, right? You only have one object of car factory. You have only one object of bike factory, and you're delegating your task. It's just about delegating your task to the create vehicle. You don't want everything. Like just think about the single responsibility principle. You don't want your client to handle the object creation. You don't want your client to have all the extra logic in the same class. You want this car factory kind of thing, which would handle the object creation of vehicle, a bike, or a class. Now, once you have got that object, you can straight away use it by calling start or stop. You don't have to create object in the client code. That is the main logic over here that we are trying to
I
discuss.
didn't get you. Client code will. I don't want to create an object in client code.
Yeah.
That
So basically, let's try to understand why we are even having a factory.
yes. Okay.
So that's the main thing, right? Now, so let's say you have a task to create object. You have a task to run that object. You have some functions in that object also, right? So you'll call that object dot function. Do you think all of these things would be required to do in some class? Let's say that is called as a client code, where the client is actually creating the object, calling the object, and calling some function as well.
Correct. Huh.
Okay. Now, I don't want to create object in the client code. Why? Because if we do it by a new object, right? On the
Hmm.
last day that also we learned that in the dependency injection that we don't want to use the object, the keyword new in the actual code or in the client side where he can actually manipulate the code a lot. And every time we create a we will call this new object, it would be repetitive, right? We'll call this new object abc, new object xyz, and whatever, right? So for that particular reason, we are just delegating our task.
Now the object will be created in whose space? Still, the factory is created in client space, right?
No, factory is a different interface itself. As you saw over here, we
Yeah,
have a
correct.
different interface. Yeah.
Huh. But ultimately, that's a class, and if I create one, I the one object is created.
Yeah, that's what we are learning over here. Ki how do we write good quality code? And we
Okay.
are trying to learn ki how do we basically divide our responsibility into different classes. How do we define different components? How we divide our components? How we break it down into smaller parts? And how do we do not reuse? How do we reuse our code instead of writing it again and again or making it duplicated? That's the main thing. So you can just assume here for now, we'll see how we are going to use it in actual coding implementations. So if you are writing some core logic in some main part, right, you won't be doing some uh, car object creation or bike object creation, then do bike dot run or car dot start or this kind of things. Everything won't be done in a single place. For that particular reason, what we are doing is we are creating an object of car factory, and this factory will basically handle all the creational part inside it. We would also do this kind of logic. We might see it somewhere. So for example, we have a vehicle factory, right? What we can do is we will have some if conditions check, and we'll have some enum that if it is a car, return a new car, if it is a bike, return a new bike. But the problem over here is it is again not open for extension. It is actually some kind of modifications that we are doing. So for that particular reason, here what we have learned is we can have a create vehicle factory, and on top of that we have a car factory, a bike factory, a truck, or a cycle factory. Now these four will automatically handle the car creational, the bike, truck, and cycle object creation inside it. I think you still have some confusion that why do we need a factory, right? Hello, are you
Yes.
yeah.
Yes. I don't understand why we need a factory.
So for now, you can just assume that we are just trying to delegate our task of creating a new OBJ. So as I
Huh.
told you, right? Let's say we have one factory class, and inside it we have if it is a car, return new car. If it is a bike, return new bike. So for example, we have 10, 15, 20 different vehicles over here, and we do some if check and return the object over here.
Yes.
This factory will have only one task of creating and returning the object. This is fine. We can have this kind of logic. That a factory, if you call this factory and you just pass on car over here, did you if you call this thing from the main code, did you actually have any uh, object creational part in the client side code? No, right? You just passed on this, and what are you doing? Vehicle v is equals to call the factory and pass on whatever parameter that you want.
Okay.
Cool.
Hmm.
You can use it in this way, and now you can use this vehicle v dot whatever object ka function you are trying to call, let's say start. So you can see that you don't have to worry about the actual object creation. Otherwise, what would you have done here? You would have done ki car c is equals to new car, then again b is equals to new car or new bike or new truck. So you see this, right? This is very cumbersome to maintain, and it's very hard to also figure out ki what you have done over here. So we don't want to handle the object creation ourselves. Rather, we want to have a factory which will just handle the object creation automatically. This is the main thing about the factory design pattern. It's good that you have raised this concern that why do we even need it. You would understand this eventually, that how beautiful this design pattern is and how
Okay.
does it automatically handle the object creation part for us.
Yeah, got it.
Yeah, cool. Now coming to a very beautiful design pattern, which is the strategy design pattern. So last day I think we discussed about a MacBook, right? And we had a keyboard, we had a mouse, we also had a screen. The main attributes that we had over here. Now let's say what we want to do is we want to have multiple uh, let's say this is one MacBook, right? We want to have a laptop ka class which will be implemented by a Mac, uh, Asus, a Dell laptop, and again let's say what else is there, Lenovo. Hmm. Okay. So what all qualities, what all mandatory features that you are seeing in a laptop? It would again be a keyboard and a mouse and a screen, right? So what would happen? So what do you guys think that what all fields should we have in the laptop class and what all fields should we have in the MacBook, Asus, and Dell and Lenovo? This is going to be an interface. So as we already know, we are going to have classes and interface and classes which will be implemented by Mac, Asus, Dell, and Lenovo. So what all fields do you guys think a laptop should have in its parent class?
All the mandatory fields maybe like
The keyboard,
Keyboard, mouse, screen.
screen, right? Now, my question over here is, let's say the MacBook has like a high performing keyboard. Similarly, Lenovo also has a high performing keyboard. Asus, let's say, have a normal keyboard. Dell also has a normal keyboard. Now it has a very high performing mouse. Similarly, high performing mouse. And now Asus, let's say, has a high performing mouse. It has a normal mouse. It has a normal screen. It has a high performing screen. It has a normal screen, and it also has a high performing screen. So as you can see that a keyboard, if we define it in the laptop class itself, it would be implemented by MacBook, it would be implemented by Asus, it would be implemented by Dell, and also by a Lenovo. But you can see, right, that a high performing keyboard is not a normal keyboard. So somehow MacBook will have a different So even though it will have a keyboard, but it's a high performing keyboard. It won't be able to use the fields that the normal laptop had. It will have again a different field, a high performing keyboard, a high performing mouse, a high performing screen. Are you guys able to get this thing? That if we use a normal keyboard, a normal mouse, and a normal screen inside the laptop, the Mac, the Lenovo will have problems because it does not have a normal keyboard and a normal mouse. It has high performing keyboards. Are you guys able to get this? So what should we do here? So instead, let's say if we, so you can see, right, this is a common field, the high performing keyboard or high performing mouse. Now let's say again we have something else. What will happen? We will again have some duplicate code, a high performing keyboard. So it does not use the parents ka keyboard. It is not using mouse keyboard. Everything is not using it, is the main thing which you have to figure here. So what would happen in this case? Are you guys seeing that the laptop ka attribute keyboard is not getting used in MacBook and Lenovo, and it is getting used only in Asus and Dell? So what should we rather have over here? We might also add a high performing keyboard in the laptop. Do you guys agree with this? If we add it, what would happen?
No, man.
No, in interface we can't add it. No? If we add, we need to implement in Dell also.
We need to implement it Dell as well. But if we implement it here, we are not following the interface segregation principle. We are not using the high performing keyboard here
Yeah.
in Asus. So it's a problem,
Hmm.
right? So what should we do here? What should be the class definition of laptop, Mac, and the other laptop brands? What do you say? Does anyone have any solution? What could be done here?
Maybe again we can create the factory kind of thing for Mac,
And
and we can define all the high performing fields here there.
so what are you saying, Ki? If we define a MacBook using a factory, we would be able to use the high performing keyboard inside the Mac, but it would be a different field altogether, right? So what you're saying is laptop may let's have keyboard, mouse, and screen, but let's have a high performing keyboard in the MacBook, isn't it?
Yeah.
That field should be there. Now what else is there? High performing mouse is also there. Screen is also there. And the same things which I have written here is also there in Lenovo. So do you guys see that the problem is I have written the same function high performing keyboard wala or mouse wala inside two different classes. Now let's say one more brand comes in. Again I have to worry key, okay, now I need to again write high performing keyboard, high performing mouse, etc. in this XYZ as well. Are you guys able to see this? Tell me what should be done here. I'm waiting for you guys.
Can't we do that? Like we have to define that keyword as an interface. Sorry, keyboard as an interface. Then there is mouse and our screen is an interface. Okay, and
Mhm.
then we have one child class for all the things like high performing keyboard, high performing mouse, high performing like screen. Okay, and we will use that thing in Mac. Like in Mac we use keyboard equals to keyboard, sorry, keyboard equals to new high performing keyboard, because the high performing keyboard is the sorry, child of
Hmm.
keyboard, so you can use that thing.
How many of you guys think that this solution is correct? I mean, how many of you guys even got what is your name, man? What did you say? Bhaskar, right?
uh,
Yeah. How many of you guys agree with Bhaskar? Ki we can have keyboard as an interface Yeah, Bhaskar, can you repeat this again so that everyone listens it again?
Yeah, so we
Hmm.
should have keyboard, ma
Yeah.
keyboard, mouse, and screen have an interface. Okay,
Okay.
yeah,
Hmm.
interface, and like extend, sorry, implement this interface to in high performing keyboard, high performing mouse, and high performing screen. Normal and
Implement what? Interface keyboard
good, yeah.
and high performing keyboard implements interface
Keyboard.
keyboard. How many of you think that this is a good solution? Again, it will have type which will be implemented, it will have a type which will be implemented, but internally it will have some slight different implementation, like fast or something. But
Yeah,
eventually it has the same function. Similarly for mouse as well, similarly for screen as well. How many of you agree that if we have a, now let's say we have a Mac book, what do we need to have? We'll have a keyboard.
yeah. Keyboard equals to new high performing.
Interface keyboard we have interface mouse, and again what do we have? We have interface screen. This is going to remain the same in MacBook, Asus, Dell, and Lenovo. This will remain the same. But at the time of creating a MacBook, what would we pass? In the interface keyboard, we would pass high performing keyboard, which is implementing the interface keyboard. And again, mouse will implement that. So do you guys see that instead of having the which was like high performing mouse or high performing keyboard functions individually in child classes, what we did, we had a strategy that instead of having it in multiple classes and we don't want to repeat it in each of the classes, we would have a interface itself for that, and that would be implemented the actual keyboard. Now, how high performing performance keyboard or normal keyboard, or let's say in future there's some more different kind of keyboard is there. Do we have to make any changes in the MacBook or Asus or Dell anywhere? If there is any kind of change in the high performing keyboard, now yeah, what was your name, man? Before, who was talking about why do we need even factory? Harita, right?
Harita, Harita.
Yeah. Now let's say we have used the MacBook M is equals to new MacBook in some place,
Yes,
okay,
okay.
in the code. Now we know that earlier it was high performance keyboard. So what we did is we passed high performance keyboard in one
Yeah,
place. Now
yeah.
let's say we have 10 places where we have used new MacBook. We would have to make changes in 10 places. Now MacBook is not using high performance keyboard. It is using small performance keyboard, let's say, or new type of keyboard. We would have
Okay.
to make changes in 10 places. Rather, if we have a factory,
Mm-hmm.
what would we do? We would just call factory dot create Mac or something, and what would we pass? We don't even need to pass anything. We just need to make changes in the factory class at one place where the new MacBook was being created, and
Okay.
we just need to make change that instead of using high performance keyboard, we just need small performance keyboard now, and the other things as it is. Do you see that how beautifully Bhaskar has said that we can use an interface keyboard and an interface mouse, an interface screen, which will be implemented by normal keyboard, a high performance keyboard, and a small performance keyboard, or different any type of keyboard or any type of mouse. And
So
this way,
when we use interface, also, I think, do we need factory?
why don't we need a factory? If let's say we have defined or used new MacBook at 10 places in 10 different places in our code base,
Okay.
one change is there of let's say a keyboard, instead of using high performance keyboard, now what were you doing initially? You are calling new MacBook and you are passing three fields that you need: high performance keyboard, small, a new, whatever mouse, whatever screen was there. So you need
Okay.
to make changes in 10 different places wherever you have initialized your MacBook.
Okay.
Did you get this?
Okay.
But if you are using a factory, you just need to make change at one place where you have used key return new MacBook. And over there, you just need to make one change, that instead of high performance keyboard, use a different type of keyboard now. How
Okay.
many of
Then
you guys?
instead of that, then in MacBook itself, if I change the keyboard type, high performance, then
No, Are, see. Again, what we discussed here is, why would we want to have a type which is like high performance, or which is like narrowing down my scope? Instead of, what we want is, we want to have a MacBook with an
that
interface
is the
keyboard.
reason we have introduced interfaces.
Correct, that's what.
Correct. Then on top of interface, again factory, that point I'm not getting.
Okay. So did you get this key? Somewhere in the code, in a lot of places, you would write new MacBook करके, you will create a new MacBook object.
Object, yes.
This could be a lot of times. Let's say you have written this 10 times in your code.
Okay.
What you have done is, you have created a object M, and you have created this object 10 times in your code
Okay.
overall.
Okay.
Earlier, you were using high performance keyboard
Okay.
over here, because you
Huh.
need to pass which type of a keyboard you want at the time of initialization. You have mentioned high performance keyboard here. You have mentioned high performance
Okay. Yeah. Let us
mouse.
say only one. Okay.
Okay.
Hmm.
Now, yeah, there's one more thing. Let's say, so if you change your keyboard type from high performance to any normal keyboard now, how many places do you think you need to make changes on your object creation of MacBook?
Okay. 10 places. But here,
Hmm.
by changing I mean, by changing the interface, can I? Okay. Now HPK is and we are creating high performance keyboard as an interface, right? We have that interface. How does
No.
interface function or class looks?
See, we have a normal interface keyboard which has one function type. Okay.
Okay.
We have a normal keyboard which is implementing the interface keyboard.
Okay.
It also has one function type, but it is overriding the actual
Yes.
interface key. It
Uh,
is having some implementation inside. I'm not worrying about the implementation here. Now, again, we
okay.
have one high performance keyboard which is implementing the interface keyboard. It has one function type. It will have some
Okay.
functionalities inside. I'm not worried about it right
Okay.
now.
Got it.
Yeah.
Next. Hmm.
Now, I want to create a MacBook. How would I know that? uh, we have to know that it will have high performance or high performance mouse and a screen as well. So
Okay.
at the time of object creation, we will pass on the type of object which will be high performance keyboard.
Okay. Got it.
And similarly, we'll have mouse and screen as well.
Okay.
So this is how we would be creating an object of a MacBook.
Correct.
But internally, MacBook will have interface keyboard, interface mouse, and interface screen.
Screen. Okay.
Correct. So it could have any kind of a keyboard. Even in future, if the mouse or keyboard changes, we don't have to worry, or we don't have to make changes in the MacBook class
Mm-hmm.
or in the interface keyboard class. We don't have to make changes. We just need to extend it. If there's a new type of keyboard coming up, we would
Mm-hmm.
extend, or we would implement the interface keyboard, and we would just at the time of initialization, we would pass that object over here.
Correct.
So you see that while creating a MacBook object, we would have to make changes at 10 places. But rather, if we have a factory method which does
Okay.
your job of MacBook creation, it will be automatically called several times, and we just need to make changes at one place.
Okay.
I
So
hope.
now, okay, can you just read the lines inside the MacBook factory? MacBook factory. Do we? Is it written somewhere?
Yeah, it's not written here, but I can write it for you.
Okay.
So you'll have a factory.
Mm-hmm.
Uh, we'll have a factory, let's say, and it has a function create laptop.
Mm.
Yeah, this would be one class. Now we would have multiple. This is an interface, okay? So we'll
Mm.
have
Mac
Mac
factory.
factory, and we'll have, let's say, Asus factory.
Okay. Then
Now inside Mac factory, we'll have a function new Mac.
new book.
Hold on. We'll have one MacBook, and here we just need to pass high performance keyboard or whatever
Yeah.
is.
Okay.
We just
Now,
need to changes at one place. Yeah, go on.
okay. Now instead of when I in the previous method when I created new 10 new MacBooks, I called new MacBook HPK 10 times. Now,
Hmm.
okay, if I want to instead of using HPK, if I want to create another MacBook, I will come to MacBook factory and in that new book, I'll change at one place. Okay.
Yeah, that's what.
Okay, got it.
Cool. So yeah, as Bhaskar has already explained, ki how would we solve this? Is everyone clear with why we actually went with an interface keyboard, an interface mouse, an interface screen, and each of the MacBook or Asus is going to just have interface keyboard and interface mouse or interface screen as the attributes inside it, and we can just pass the type of keyboard or mouse we use at the time of object creation. Does anyone have a doubt over here or has a solution which is better than this? So everyone is clear, right? Till now, what was the problem statement and how Bhaskar has suggested that we can follow the interface approach to create MacBook, Asus, Dell with different type of keyboards and different type of mouses. Is everyone clear here? Yeah, just give me a +1. I hope everyone is clear in the chat. If anyone has still doubt, okay, cool. Okay. ठीक है, तो I am assuming everyone understood what the strategy pattern over here is. So I have one more example which I have written. So here, as you can see, we have an interface which is the payment strategy, and we want to pay some amount. So what are the different ways of paying the amount? We have a credit card payment, which is implementing the payment strategy, and it will just pay. So we'll just override that function pay over here, and it will do some payment amount, whatever was required using the credit card and the number. We have PayPal payment, which is implementing the payment strategy, and again it does some kind of payment part. Now we have a shopping cart. It is having a payment strategy, which is an interface, as you can see over here. We are not using uh, s- any child classes over here in the shopping cart. Why? Because we can change any kind of strategy of payment that we want to use in future. And what are we doing here? We are trying to set the payment strategy instead of calling the constructor of shopping cart where we could have set the payment strategy. We are just doing a set payment strategy. And what are we passing over here? We are passing the type of strategy that we want to use. So at the time of object creation, we would pass on the payment strategy. It could either be credit card, or it could be PayPal, or in future it could be UPI or anything. So at the time of checkout, we are just doing payment strategy.pay. So in future, if the UPI comes in, do you think we need to make changes in shopping cart or PayPal or credit card or payment interface anywhere? Is anyone having any doubt here that
So
or
how it is different from factory design pattern?
factory is a different thing? Strategy design pattern, factory is just enabling you to create the objects. It is not having any properties of the class that we are going to use in that. So what I have explained in the factory class, factory design pattern is that factory design pattern helps you delegate your object creation at one place. Did you get this?
Okay.
So factory and strategy both are different things, completely different things, even though the logic could be same at some of the places. But I'm not going to say that factory and strategy are at all uh, coinciding at any place. So factory is only responsible for creating objects, and that is a type of pattern where we are responsible for taking care that if we want to have any object created, we'll just call that factory method and we'll just use it as it is. The strategy is kind of something where, let's say, you have a parent class and you have some kind of uh, objects or attribute that you want to use in your child class. But the problem in using child class is that if there is a slight change, right, or if there are multiple different types of keyboards are there or mouses are there, so again you will have to make changes, and you would write a lot of repetitive code because your parent is having something, your child is having something different, and this child is also having something in the different child. That's what we discussed in the MacBook, right? That if there is a high performance keyboard in Lenovo and MacBook, what should be done here? We cannot have high performance keyboard in laptop, and if we have it, then we have a problem in Asus and lap and Dell. So for that particular reason, we said that we don't want to have high performance keyboard or a mouse as a field inside the child classes. Rather, we will have an interface, and we would decide that at the time of object creation that what kind of keyboard we want to use or what kind of a mouse do we want to use. That will be handled at that time. So as you can see here, if we add any kind of UPI payment, do you guys see that we won't have to touch the code at all of the PayPal or credit card
Uh,
payment or
Aman,
strategy?
can you repeat this payment strategy example? Actually, I did not get. Though I'm listening to you, but somehow
Okay,
I'm not getting. Can you repeat it
okay,
once?
okay, cool. So I'll just repeat this what we are trying to do here. So we have an interface payment strategy and we want to make a payment. So there's a function called pay. What
Okay.
uh, what the child classes of credit card and PayPal payment is doing, it is just overriding the function pay, and it is using some different logic of pay in its own function. So it has credit card number and name, whereas a PayPal will have an email which would be used at the time of payment up,
Okay.
right?
Mm-hmm.
So as you can see, if we want to make any kind of a payment, what
Okay.
what should be done here? Like a shopping cart is not having any hard coded credit card or PayPal payment
Uh,
method here. It is having a interface which is
nice,
called
nice.
as
Yeah.
hmm,
Payment strategy.
payment strategy. So
Okay.
here what we are doing is at the time of the set payment strategy, we are just passing the type of payment strategy in this particular method, and this is
Oh,
what we are going to use. So if we pass on credit card, we would use credit card payment. If we pass on the PayPal, we would use PayPal. And if
suppose
we
UPI come, then I have to create one more child class.
correct,
Uh, being base class being, parent class being the payment strategy.
yes,
Okay. Then that's it, right?
yeah, that's it. You don't have to touch the previously tested already uh, working code. You don't have to do anything over there. You just
Okay.
need one child class
With UPI,
UPI,
whose name is
and
UPA pay.
it implements the payment strategy. That's it, and it will just override the method pay,
Okay.
and it will still do whatever kind of logic it wants to do in its own method. So the previously existing code does not have to be changed, and we can modify.
Actually,
uh,
this is the basic philosophy behind parent and child, right? So,
hmm.
why are we studying this under separate called strategy design?
Okay, so this is also a proper parent and child, right? The MacBook is
Yeah.
having a keyboard, a mouse, and a screen. But what happened over here was there could be a high performance keyboard, there could be a high performance mouse, there could be high performance screen that we discussed earlier.
Okay.
Correct? Now, if we have the keyboard, mouse, and screen as it is in the parent, and we are just overriding we are just using that fields inside the MacBook, what would happen? We would have to have a different field, a high performance keyboard and a high
Correct,
performance
correct.
over here. And
Huh.
if we write, let's say we write it as well in the child class of MacBook, but
Hmm.
the same thing is getting used in Lenovo, we would have to copy this thing, same thing over here as well.
Correct. Huh.
Did you see that? So we came up with a strategy that instead of me having multiple uh, implementations of a single function at different places, what I want to do is I want to have a generic keyboard or a generic mouse, and it will be implemented by any different kind of high performance keyboard or normal keyboard. And in this way we are defining a strategy that how do we want to use this keyboard, and it's not straight away that a laptop having a keyboard is getting used in the child. We are using some kind of a strategy over here, as you can see, right?
Okay. That strategy is not using interface function, no?
This is also like a keyboard will have, as I explained over here, right? Interface keyboard will have one function type which is not implementing anything,
Correct. Huh.
but
But
child will have its
in the
own.
child, I mean, we will
All right.
define one more child, not yeah, normal keyboard, and another child high performance keyboard, and
Hmm.
we define what type does in that particular child.
Yeah, correct.
Okay.
Did you get that?
Yeah, yeah. Okay.
1 second, man.
So, Aman, I have doubt between these two design patterns. Sorry for that, like factory and strategy. So in strategy, as you mentioned, we have like one interface like payment strategy, right? In that
Yeah.
we are defining a method called pay, and
Hmm.
we have multiple interfaces like credit card and PayPal and all, and where we are overriding this pay method accordingly. And from the client class, like shopping cart, we are passing the payment strategy, whatever it is, like credit card or UPI or whatever. So does we don't like it is the same thing we are doing in the factory also. Like we can have like one factory called payment strategy. We could have multiple factory like credit card factory, UPI factory, or in that basically we can override this pay method, and from client we are basically calling that factory thing. Isn't it the same thing? So why we are giving the different pattern name?
Okay, so you are slightly going into the wrong direction. As I told you, so let's come back to factory again for a minute. Okay, see, we so a I'll just come down over here. Hmm. So what is the main function of a factory? Bhaskar, can you tell me what is the main function of factory over here? What does this do? If we have defined a vehicle factory, what does this do?
Like factory, just like by the name suggests, we use factory design pattern to create factory only. Okay,
We will just create some kind of an object over here.
create object
We are
only.
only worried about that here. We have, let's say, if it is, let's say, a type of car, then return an object of car. Let's say if it is a bike, we will just return an object and will return, let's say, object of bike here. This is the main use case of a factory design pattern. Okay, to delegate our new keyboard into multiple different places or in the client code into one place which is called as factory class. This is factory design pattern, that we want to delegate our object creation part into one place which is called as factory class. Now coming to the strategy class. Okay, uh, so strategy class says that if there is a parent class, which would be implemented by multiple child classes, and it is having some attribute, let's say a keyboard, which would be used in different childs as well. It will also have a keyboard. But what would happen if the type of keyboard in this child is different than this child? So it is having, let's say, a high performance keyboard. This is also high performance keyboard. So you can see, right, key the parent's keyboard is not getting used over here, even though the attribute should be used in the child. This is what a parent and a child relationship does, that everything we define in the parent must be used in the child. That is the plan, right? But what is happening here? This high performance keyboard is not getting used in this wala class, and this keyboard is not getting used in this wala class. So there is some kind of problem that we were seeing. So for that particular reason, we said, key, take this field out and have it implemented as an interface somewhere. And wherever we want to use it, we will just plug it over there. That's it. So it will be an interface keyboard. It is also an interface keyboard now. It is also an interface keyboard. It is also an interface keyboard. But now the thing is, if we want to use this keyboard, the Mac keyboard, while creating the object, I'm not saying ki we need to create an object, but while creating an object, I'll pass on high performance keyboard over here. For Asus, I'll pass normal keyboard over here, which is implemented by the interface keyboard. So you see the difference, right? The problem statement over here is that the parent attribute is not getting used. So we went for a different strategy of using that to have an interface. Whereas in factory, we were only concerned about creating the object. So somehow it will use also factory over here. Internally, it might use a factory. How would we create an object of MacBook? We will use
Yeah.
factory.
Okay, so on top of factory, basically we are adding some logic to create the high performance keyboard or mouse kind of.
You can say it like that. The task of factory is to create an object, but the task of strategy is to handle some kind of a keyword or an attribute which would be used across many different places. But how do we plug it? So for plugging it, we are using an interface. So
Hmm.
interface we can plug anywhere. Now that interface will be implemented by many different classes. And while creating an object, we can just pass on the particular class of that child कि ठीक है, I need high performance to pass it over here. तो we are just worried कि ठीक है, एक object तो बन ही रहा है from the factory, but the main task over here is to make sure that attributes are getting used. Now I hope
Okay.
this is clear
Yeah,
to everyone.
but
Hmm.
this thing is not implemented with this payment strategy, right? Payment strategy is simply like credit card and PayPal.
Can you see this interface?
Yeah, this pay only.
This is the interface that we have worried about. So if there would have been a child class which is directly implementing a credit class payment, credit card payment, it would be a problem for us. क्योंकि let's say this shop there, let's say in future the credit card payment is not getting used, so we'll have to change every place where the credit card payment was getting used. But if it is a payment strategy, do you think if the shopping cart payment strategy what we have written here, if we would have written the credit card payment instead of a payment strategy, you see, right, the this code would have been changed. But with an interface we don't even need to change it. We don't even need to change the payment strategy, and we can extend it as much as we want. And while creating the uh, payment strategy, we create it using new keyword, but we can use the factory method here also. We are not worried about the factory over here, so we just use it as it is for once. But if the use case was to have multiple object creation of credit card payment, we won't go with this approach. But since we were using it only for once, we used it. We set the card payment strategy as credit card payment, and then we do a card.checkout. So we don't need to worry here ki what kind of a credit card is there, what kind of a UPI is there, or whatever is there. We just need to create an object of PayPal, or we just need to create a object of credit card. We uh, we set it in the credit card in the payment strategy, and then we just do a checkout of that.
Aman, see, you said since we are doing for only one time, we created a credit card using new credit card.
Mhm.
Otherwise, if we would have created a factory of, I mean, credit card factory, right?
Yeah.
Okay.
No, right, you got it right. So for once we can do it if we are only concerned about the other logic. So we are not concerned about the factory or object creation here. We are only worried कि ठीक है, we just want to
Method.
have an object, so we use it once. But if you are using it for more than once, twice, three times, 10 times, as you saw it in the previous example, right? We would have to change a lot of things. Let's say right now there's only one parameter, so we'll change one parameter here. But in future there are, let's say, two or three parameters in the credit card payment. We need to change it everywhere. Or rather, we can have one factory method where we change it once and it is done.
Mhm.
And it is easy to debug as well.
Okay.
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 Yeah.
Does anyone have a doubt in any of the things that I have told? Okay, cool. ठीक है, so I hope everyone is clear with the four design patterns that we have learned. We are now going to learn about the decorator design pattern, but before that I wanted to show you how do we actually take the requirement and component level design. So if you are given an actual problem, how would you go about it? It will take some time, so I just want to go to that, and then we can come to the decorator design pattern because it's very easy to understand. So uh, let's say we are designing a parking lot. Okay, and you are given a question. Okay, design a parking lot. Design, how would you go about this? So what is the strategy that you would be using to solve this question? And for just for your reference, LLD problem is usually given to you for 1 hour. So how would you go about it? I'll just give you since we don't have that much of time here in this class, and everyone might be going to their weekend parties and all, so I won't take a lot of time. So I'll explain to you how would you go about this. So first of all, the person who is giving you this problem, the parking lot design, will explain to you कि ठीक है, you're given document, you'll read through it कि what is the problem statement, and how do you approach that problem is what we are trying to discuss over here. Okay, if anyone has any doubt in the middle as well, just let me know. So going to the parking lot design, first of all you need to read the problem statement and review what all functionalities and constraints that person has given in that document. So I just tell you that you are supposed to solve that uh, parking design problem. How would you do it? So you can start by asking the questions from the document itself. Since we don't have any document over here, we can ask the interviewer itself that okay, what all things that you want. So for that, you'll have to tell him that ठीक है, we are trying to design a parking lot system. So mm, here we'll do the requirement analysis, requirement gathering. This is a very important part in an actual LLD problem. The person who has given you the problem will expect you to take all the requirements from him in 5 to 10 minutes, and the main task that he wants to check from you is that how good are you in gathering the requirements if you are given any ambiguous problem. Okay, so first of all you need to do the requirement gathering, and you'll be given 5 to 10 minutes. You should take 5 to 10 minutes to gather all the requirements. To gather the requirements, and the person who has given you this problem statement definitely wants you to know that how you are good at requirement gathering, how are you able to break down the problem into smaller parts, how are you able to use all your design patterns that you have learned. So in this way, he or she would be basically looking at your object oriented skills, your design patterns, and your problem solving ability. So since we have lesser time, let's just think what all things we need in a parking lot. So guys, please help me over here. What all things do we need in a parking lot? So yeah, just waiting for you guys. Like, what should we have in a parking lot design?
Token of the car.
So always start from the very beginning, okay?
Number
So
of parking lots. I mean, number of
yeah.
spaces.
Lots.
So first of all, we'll have number of parking spots that Harita said. This is a very initial part or initial point that we need to think of. Now we have number of parking spots. What else can you think of? There would be entry and exit points.
Uh, yeah.
Entry slash exit terminals. There could be more than one entry and more than one exit points. What else?
A counter that displays how many spots are occupied and how many are empty.
That would be something, but it's out of scope in the requirement gathering, I would say.
Okay. Okay.
So at the time of entry, the
Yeah.
ticket
Okay. Ticket price. Huh?
ticket generation at
For two-wheeler and other.
correct. We would have types of parking spot for two wheeler, for four wheeler, for SUV, or different things as well, whatever could be coming. Then there would be some rates,
Hmm.
hourly rates. What else? There would be type of payment,
Huh.
could be either cash, card, UPI. What else can you think of? At the time of exit, we will pay amount
Huh.
and we will release the parking spot that we have taken.
Okay.
What else can you think of? There could be some kind of additional monitoring system like CCTV and all in a parking spot
Mm-hmm.
that could come into the picture. But more or less, I guess this is fine for us. Now you have 5 to 10 minutes to like gather all the requirements, right? Now you can ask him that what all different type of parking spots do you see? So you can say two-wheeler, there could be four-wheeler, there could be some spots for let's say truck and what else? Yeah, this is fine, I guess. Then we have exit and entry terminals. There would also be very important thing. How would you put the vehicle in which spot? Strategy basically. Strategy to park vehicle. Park in a spot. Like I mean, the nearest one are you going to pick? Or nearest to entry or nearest to exit? Correct. This we have to clear with the interviewer. Either you want to have a entry at the parking spot nearest to the entry or nearest to exit. And also we talked about the hourly rates, but again we'll have to figure out ki if it is a weekend then it will be costly, if it is a normal day then it will be cheaper. Correct? Did you get this? Number of parking spots, there could be multiple floors and there could be multiple sections inside it. Floor में जाकर inside some section is there, etc etc. Do you think this is mostly fine for us, ki this is a good enough requirement for us to design in 30 to 45 minutes? You will be left with only 30 to 45 minutes. Hmm. after you are done with the requirement gathering and you have spoken to him that how would you be going about it. Okay. Now, what all things do you think? Now, this is a very good requirement gathering. Is anyone having any doubt in this part that why did we pick number of parking spots or entry and exit? Anything? Tell me, guys. We have to be quick. If nobody is having any doubt, cool. If anyone has a doubt, just uh, okay. हाँ ठीक है. If anyone has any doubt now, just unmute yourself and speak out. I won't be looking at the chats. That's why. Now, after you are done with your requirement gathering, you have to define your actors or classes basically, or interface. Always use interface. Never use any classes. I mean, the concrete classes. Always use interfaces because you always want to show the interviewer that you know that you always are looking for open for extension and close for modification. This thing you have to make sure. This would give an impression to your interviewer that you know LLD properly and you are following your design patterns from the very start. Use uh, all the design patterns that you know from the very start that we discussed, right? Strategy to the park, strategy to park in a spot, nearest to entry or nearest to exit. This kind of things you can always explain. Design patterns you have to use. This thing you have to make sure. Now, what all actors do you see here? Come on, guys, tell me this thing. You have to be a bit quick because we are short on time. We have done the requirement analysis, right? So what do you see here? Just look at the requirements only. We have number of parking spots. So
Rates could be one of the interface.
what?
Rate according to the type of vehicle.
Okay, so we will start from the very uh, important thing or maybe the base things. So we would need a parking lot, right? Which would be the very important, the most important actor, which will have parking spots, which will have the ticket prices and all, which would be the main actor, you could say, right? We would have one parking lot. What else do you think we'll have? Do you guys see the entry and exit terminals? This is the main one, right? Why? Because we'll have to calculate price here. We'll have to print tickets and give it to the person. There would be a generic interface which would be the terminal. It would be implemented by entry terminal and exit terminal. That would have calculate price at the exit and print ticket at the starting. What else? We would have a
Type,
parking lot.
type of vehicle.
We'll have a parking spot, right? You said type of vehicle.
Yeah, like two-wheeler, four-wheeler.
Mm, yeah. This is uh, this is somewhat correct, but I have seen in general that vehicle type. Do we actually need a vehicle type, or we only need the type of parking spot? So if it is a two-wheeler spot, why do you need to know what type of vehicle is it?
Yeah, yeah. Like parking spot will cover this thing.
We will have to just worry about the type of parking spot this thing is. We have four-wheeler and what do we have? A truck. So in that case, we don't need a vehicle. We'll automatically consider it from the parking spot. If it is two-wheeler, we already know that it's a two-wheeler type. We don't need to worry about vehicle type. This is a very common mistake, very which people make, that they have defined parking spot and they have defined the vehicle type as well. But we don't want redundant classes to be written here, right? What will you do in vehicle type? You'll have again four-wheeler type. You'll have two-wheeler type, isn't it? You'll have a truck.
Yeah, that will cover in parking spot.
So we don't need this. Everyone clear with this? What else, guys? What else can you think of? What else? What we have covered is parking lot, Entry and exit. We have a parking spot. What else? Can you think of ticket? We need a ticket, right? What will a ticket have? The in time and the type of parking spot that person has taken. So we need it at the time of calculating the total amount. So if it is, let's say, 2 hours, and if it is a car, so car ke liye, let's say we have 60 rupees, bike ke liye 20 rupees, truck ke liye 100 rupees. So 2 into 60 will need at the time of calculating the total amount. I hope this is clear to you, right? What else do we need after ticket? We have ticket, we have parking spot, we have,
Payment strategy.
correct, we have user payment. We can have, again, different types, cash and card. Let's say the major ones. What else?
Invoice.
Huh?
Invoice.
Invoice. All right, that can be said, but the ticket will automatically. ठीक है, we'll just return that. But yeah, just make sure that if it is a 30-minute interview, which you have 30 or 45, you don't use the unimportant ones. Like invoices generally handled at the time of exit, right? You have made your payment, it is successful, now you'll get an invoice. What will you do with that? It's not required in a parking lot in general, but yeah, you can say it here.
Yeah.
Mm,
Okay.
okay. What else do you think we would need? Tell me, guys. I hope this is clear to you, right? The actors that we have defined. Now, what else do we want to do? We want to define the different type of interfaces. So one thing we can take care is, instead of having invoice and payment in the actors, we can have these two in the interfaces only. The main actors are to make sure that our flow is working end to end properly. That we have a parking lot, we have entry and exit terminals. We'll calculate the price, and we will choose the parking spot, and then we'll generate the ticket and calculate the price. Payment and
Hello.
invoice. Yeah,
So as for the actors, it would be same, like the test case would be same as
sorry.
with the actors. So what test that we would need to define would be same as the actors.
Test cases for what are you saying?
So I read the last point. There was something written like test cases. At that point, my screen got disconnected.
Okay. No,
Yes.
we did not
So
discuss anything about the test cases yet.
okay,
Yeah.
I guess I read it somewhere on the
Yeah, yeah.
screen.
That
Yes,
is
this
a
part.
point which we would discuss, that what this is a very last part. We have not discussed about test cases yet. We have only discussed about ki, how do we go about the requirement gathering, how do we define our interfaces. Now we are
Mhm.
into the place where we are defining our interfaces. We have defined actors, now we
So
will define the interfaces.
I just wanted to clarify, like, would it be same like the actors and the test cases? Test cases would be based on the actors, right?
Yeah, you are right. Test cases,
Okay.
all the different type of functionalities that you have written, right? It's always
Mhm.
good to just have one unit test case for them.
Okay.
So if you are writing some actor, and you have a proper flow for that, let's say you did some payment, so you have written some function, and let's say you want to test it out. So it's always good to have a test case so that you know that your payment whatever section is working fine. It's like that. You want to test your functionalities over there. Now coming to the interfaces. Okay, we have, let's say, a parking spot. I'll just quickly explain to you. So let's say we have a parking spot. What do you guys think we should be having over here? We have two-wheeler, we have four-wheeler, and we have truck. So what should be the different way we can define a parking spot? Should we have an interface parking spot, or we should have an enum, something like two-wheeler, yeah, four-wheeler, and truck?
See, if those are the only three types of vehicles, and if we know for sure, then we can go ahead with enum.
Mhm.
Otherwise, yes, we need an interface, right?
Yeah, correct. So we always want to have open for extension and closed for modification. So we'll never go with enum in this case. We'll always have an interface parking spot, because you never know, right? In future, what would the different type of vehicle come in? So we'll have an interface parking spot, which would be implemented by two-wheeler. Again, it would be implemented by a four-wheeler. We can implement it using a truck. And let's say in future, we have something else as well. So this is how we would implement a parking spot. Okay. And what would a parking spot have? It would have an ID and
Empty or not? I mean, vacant or not?
sorry,
Whether it's occupied or not.
yeah, reserve करके.
Okay.
So let's say we want to reserve this parking spot. So we'll have one function reserve. If it is, we will always check for that case that if it is empty, then only reserve it. Or the other thing would be to release it. We just want to reserve, but before reserving, we would check if it is empty or not. And releasing it MP, we'll check if it is actually occupied by something else or not. Getting me? Now we are clear with our parking spot, so we will have this. What all interfaces, guys, you can think of apart from this? If anyone has any idea about it. We are short on time, we're already over 5. If we can just quickly,
A ticket, maybe.
we'll have one parking ticket, isn't it?
Yeah,
Correct.
What all fields do you see over here? It will have an ID.
yeah, ID, price, type of vehicle.
And
It
the parking spot in which it was parked.
Yeah,
will have parking spot ID. What else?
maybe price, how much we want to use.
Vehicle number.
Correct. We'll have vehicle number, and we'll also have parking spot type to calculate the price at the end. And we'll have the time as well when that person went inside it. So what will the type help us to define? It will have some cost for each different type, and time say will calculate the cost again. So we'll do a multiplication of these two to calculate the price. Now, what is
Can
really
generate invoice here.
invoice? We won't need it on a ticket. Yeah, we don't need it in a ticket, I guess. Yeah, we would need a terminal, I guess, terminal exit or terminal. So why do we need it? We will need it because let's say a person is entering from terminal 4. So while assigning him some parking spot, we would need to know which terminal he's at. So to give him a place which is nearest to that terminal, we just need that. So we'll just need this terminal to get ID. The terminal gate which I'm talking about, right? Now, what else do you think? So this terminal will have is it will be a interface. It will have entry terminal and then it will have exit terminal. At the time of entry, we will get the ticket, right? And at the exit, what would we get? It will take the ticket and it will return you the price or something. At that time of exit, it'll take the ticket what you have got, right? It will have some kind of parking spot type for generating your ticket, your vehicle, etc., vehicle number. Mm, yeah. What else do you think you need? A payment processor, right? What would this do? Process amount using some ticket number, or I mean, whatever amount it needs to pay. It can be implemented by what? Cash, UPI, or card. So, you guys comfortable, right? If we extend by 5-10 minutes.
Yeah, it's okay.
Cool. So, what else you guys see over here that we would need? So, you guys like till now with me, right? Ki we need a payment processor. We need terminal gates, the ticket. We would need the parking spot. What else are we missing over here, which is very important?
Monitoring some
There would be
CCTV.
some strategy to park the vehicle. It could change in the future as well. So we'll have an interface which is called as parking strategy. It will take the vehicle type or the type of parking spot, or and it will have one function to park the vehicle. Now we will be implementing it. Let's say we have nearest to entry, something like this. We'll have one class which will implement the parking strategy, and it could be some uh, generic strategy.
Aman, you said a parking strategy we will be implementing using interface. So can you
Correct.
just write the code how to like now I will be using a keyword interface in front of parking strategy, right?
Yeah, something like this. And
Okay.
these functions will not be implemented. It will just be a definition of it,
Okay.
right?
Okay.
So now we interface is just like as I already told you in the last class, that it's a 100%
Like
abstract class. You would not be implementing the functions over there. So I'm just writing it. I mean, I'm not writing it very clearly, but yeah, if you have any doubt, you can ask me always. So
okay.
we'll have a park function, and entry to nearest to entry wala parking strategy will take what can it take? It will take some terminal ID, this park, right? What would we need here? We would need a terminal ID. So we'll just have the same structure in the parent as well. I'm not writing it here, but we'll have a terminal ID, the parking spot type, and some logic inside it to just park it over here. We can later on implement it as it is as we want. So we don't need to worry about this thing right now. And there would be something called as, which we forgot, key tariff calculator. How would we even calculate the price, isn't it? Its purpose is to calculate the price. And what would this take? Some kind of,
Parking spot type.
somehow it will take the type of the car or the vehicle, and the time as well in hours, or whatever is the different way that they are taking, right? It could be time in hours or time in minutes. Later on, somehow they are just overriding it inside the function, but we don't need to worry about it. The parking spot type. So roughly, as you guys can see, we have defined our interfaces, we have defined our actors, what are there, and we have gathered our requirements over here. Now, as you can see, we have taken around 30 minutes to, yeah, roughly around we started at 40, right? So we've taken 30 minutes of time to gather our requirements. We have our actors, we have our interfaces. Now, I won't take a lot of your time after this, but we just need to make some kind of a diagram of an activity diagram, which I explained to you, right, before. Activity diagram or sequence diagram, which is also the same thing as activity diagram. So we just need to explain कि ठीक है, we'll have one car which is coming in, and we have parking spots with vacant places or reserved places. If a car comes from, let's say, there are multiple floors, there are multiple terminals. This is, let's say, at terminal 1, this is terminal 2, could be terminal 3, terminal 4, could be terminal 5, could be terminal 6. So just having a small diagram to show that how would your flow be looking like is enough for the interviewer to know that you are aware of it. Mostly they will judge you on the basis of how you have defined your interfaces, how you have taken your requirements, and how you have defined your actors. This is the very important part of any system design interview in an LLD round, which would be of mostly 1 hour. So after you have done this, if you are asked a machine coding round, which is usually of 2.5 to 3 hours, over there you'll have to write the entire code. Don't go into the very internals of how you would implement the functions. We would be going into that kind of thing in the later classes. We'll be following some real life examples, but for now you can assume that you don't need to go into the very deep parts of the functions. And once you're done with your actors, interfaces, and everything, you just need to write one uh, working code where you'll call some uh, functions. You are showing that okay, you have bought this item, or like, let's say you have taken this parking spot, the time was this, you exited at this time, so how much time you stayed in and how much was the price. These things should be like eventually shown in the test case. If you are comfortable with writing that, you should be doing it. And apart from that, I guess you can always talk to him that what is the interviewer expecting from you, that whether he needs an fully tested code or he just needs the interfaces and the what do you say, the actors or the activity diagram. So this would be enough for you to easily clear any LLD round, is what I'm going to say. And this is mostly about the practice. If you practice a few more problems, you would know how you do a requirement gathering, how you would define actors, how would you define your interfaces. And never use any hard coded class, always use interfaces, so that the person knows that you are very comfortable with designing it, I mean, in an extensible way. So you'll always have to worry about that. I think, yeah, this should be fine. We will cover the decorator design pattern in our next class. We did not have this much of time. And I think, yeah, does anyone have any doubt after this? I think we went pretty quickly in the understanding requirements and component level design. But if you guys have any doubts, you can always ping me and you can always ask me in the next class. I'll be coming over there as well. So we were mostly out of time, so we had to go faster. But yeah, if you guys have any doubts, you can always ping me. You can always message me, and I'll be happy to help you guys. So if you guys have any doubts right now, anyone?
Yeah, hi, Aman.
Yeah.
This is regarding not about this particular pattern or something.
Okay.
So, as we have discussed, this is the round that is we will be going on through this whole LLD round. So, suppose we are having an interview in a company, so we will be going through this. So my question is, with this, the yesterday that solid principles and this or this design patterns, can we do or can we get a successful output of that interview from these two classes?
Yeah, very much. Now it's always about more practice, I would say. And with these two, I would say you will not be able to, since I've already only told you about 4 or 5 design patterns, right? There are multiple design patterns which are used in some different type of questions, different type of problems, and those might be required. But if it's a very generic problem like a parking spot, you can definitely go about it. We did not cover any more design patterns, right?
Yes,
But you
yes,
are
correct,
still
correct.
able to understand most of the things, and I guess if you practice a bit more, you would yourself be able to explain to the interviewer that how are you going this, how are you doing this. And yeah, I think if to answer your question shortly, this is just the basics. There would be a few more things that you might need to require, but yeah, you can definitely uh, give an interview with the help of this knowledge as well if you have understood these things properly.
Yeah, okay, got it. Thank you.
Okay, cool. Anyone else having any doubts? Or else we can just finish this class and then we can meet again tomorrow. Okay, then cool, guys. It was very nice talking to you. You were pretty amazing today. So, yeah, let's meet again tomorrow and we'll have a discussion of a real life problem. Cool. Okay. Thank you. Bye bye.